at catalysis today. Catalysis. Simply just look at the review. I reviewed catalysis. Okay, we're not going deep based on what we are the course outline. So we just have to talk about catalysis and then talk about the types of catalysis and then give example. That will be all. But before I talk about catalysis, what is a catalyst? Because the word catalysis is different from the word catalyst. Look at the word catalysis. Catalysis is different from what we call catalyst. Okay? So what is a catalyst? First of all, a catalyst is simply a substance that speeds up the rate of a reaction without being used up in that reaction, without taking part in that reaction. Okay? So catalyst alters the rate at which the reaction goes. Okay? It speeds it up, but it doesn't take part, it doesn't change, it remains the same throughout the reaction process. So now, what is now catalysis? Catalysis is that speed up or that change that happens in a reaction when a catalyst is being what? Added to the reaction. Okay? So, and there are two types of catalysis at this level. Just know this one. We have what we call the homogeneous catalysis and what we call the heterogeneous what? Catalysis. Now, for a homogeneous catalysis, the catalyst that is speeding up that reaction is in the same phase or in the same state of the reactants and the product. Okay? What it means is that if the reactants are in solid state, the catalyst will also be in solid state. If the reactants are in gaseous form, the catalyst will also be in gaseous form. If the reactants are in aqueous form, the catalyst will also be in aqueous form. Okay? So an example is hydrolysis of an ester. Okay? An example of homogeneous catalysis is hydrolysis. Hydrolysis of an ester. Now, why is hydrolysis of an ester a homogeneous catalysis? It is a homogeneous catalysis because the ester, remember that esters are RCOOR. This ester are in aqueous form, okay? And you have water, which is in aqueous form too. So, and the catalyst for this hydrolysis is an acid, a mineral acid. So the acid is also in an aqueous form. Okay, so when this happens, you definitely have the alkanoic acid and what? And the alcohol. Okay, so hydrolysis of an ester is a homogeneous catalysis. Why? Because the ester is in aqueous. Water is in aqueous form. Okay, or because you're going to add this catalysis, this catalyst. Okay, this catalyst is in aqueous form, so automatically the water will be in aqueous form too. So this will give you an alkanoic acid and alcohol. So why is it a homogeneous catalysis? Because all these things are in the same phase, aqueous. Now, the next one is heterogeneous catalysis. A heterogeneous catalysis is a catalysis or a change in a reaction that happens when the catalyst is in a different physical state. The catalyst is different from the reactant. An example of this one is catalytic hydrogenation. Catalytic hydrogenation of an alkane. Okay, so this is an example of a homogeneous catalysis. Why is it a homogeneous catalysis? Because the alkane, let's pick an alkane. Let's use the word ethane. Let us use ethane as the first alkane. When you undergo this catalysis, that is reacting ethane, and remember that ethane is in gaseous form, and hydrogen also is in gaseous form. Okay, but the catalyst for this reaction is usually a metal. You can either use platinum or palladium or nickel. Okay, these are the three catalysts that we use for hydrogenation of an alkane. So in the presence of this catalyst, these guys are in solid state. Why these are in gaseous form? So watch, gaseous form, but these guys are in solid state. Okay, so because of that, we say that this catalysis is a heterogeneous catalysis because the reactant and the catalyst are in different states. So this will definitely give you an alkane when you are done with the what? Hydrogenation. You have something like this. Okay, so hydrogenation of an alkane to get alkane is a heterogeneous catalysis. So catalysis are of two types for this level. So notice homogeneous catalysis and heterogeneous. So check the material and the app. You will see more examples on this catalysis and more examples of homogeneous catalysis and heterogeneous catalysis.